The volume V and surface area of a sphere of radius r are given by volume is 4/3 pi r cubed, surface area is 4 pi r squared. The volume of a sphere increases at a rate of 200 centimeters cubed per second. What they're telling us here is dV dt, how the volume changes with time. At the instant when the radius of the sphere is 10 centimeters, we want to find the rate of increase of the radius. So here we're required to find dr dt. Now, dV dr, which we can find from here, is going to be, well, the 3 comes down and multiplies, which will cancel with that 3 there. So we're going to get 4 pi r squared. Now we want dr dt. Forming a chain, we can make that with dr dv dv dt. So dv dr is 4 pi r squared. So dr dv will be 1 over 4 pi r squared. And dv dt, we were told, was 200. So that's going to be 1, and we want it when r is 10. So 1 over 4 times pi times 100 times 200. We can do some bit of cancelling here. And so there. So that's actually going to be 1 over 2 pi, which is approximately 0.159. And that's radius, so that would be in centimeters per second. I'd rather write that as that, or you can write it like that. Okay, rate of increase of the surface area. So now we're required to find dA dt. Okay, so we need a chain that's going to give us dA dt. Well, we can find, sorry, they've used S, so I'm just going to S for surface area, that's fine. So we can do ds dr, and then we could do dr dv, and follow that with dv dt. And I think if you actually treated these as fractions, you could see those drs would cancel, those dv's would cancel, and we're left with ds dt, which is what we actually want. So ds dr, so differentiate that, would give us 8 pi r. dr dv, we've had that, 1 over 4 pi squared, and dv dt is 200, and that's 8 times pi times 10, and we'd already worked out that this one is 1 over 2 pi. So we can have a pi cancelling there, that going there, and that leaves us with 40 centimeters squared per second.